Goes through 0?
It does go through 0. What about the shape?
Straight.
Sorry?
Straight.
No, displacement would not be straight.
Sine wave?
No, not like a sine wave. Hint, it will still be a parabola for this problem. All right, so let's drop back here. I'm going to assume all of you have incredible eyesight. All right, so there's an orange mark right here, and I'm hoping you can see that. Okay, you're the farthest away. You're the oldest. Okay, you can see it?
No, can't.
Again, all right, there's an orange mark right here. I've got plus signs up here and negative signs down here. Or if you just want, here's 0, positive, negative. If I'm plotting position versus time, that's basically, it's like a number line right there. So it's positive the entire time. If I'm looking at displacement, all I'm doing is I'm taking this and I'm just shifting it up to there so that my reference is the starting point. The only difference between position and displacement graph is it shifts. The displacement graph will look almost exactly like that, except it starts at 0. So if whatever color that is, red, is my displacement graph, my position graph is just shifted up from my displacement. Or shifted, in general, it's just shifted up or down. So there's no change to the slope, and so velocity is also the slope of the displacement versus time, because the slopes are the same. All right, I have enough time to at least present a test level problem. It'd be nice if you try to figure it out before you come back on Tuesday. But higher priority is to watch the videos. Questions before I present what would be a test level problem? And I will tell you, there will be a plus minus 0 problem. Will be the last problem of the first test will be one of those. You have been warned. It starts here, moving up. B is when it reaches the peak, and then it starts sliding back down. C, it gets to this point. D, it is here. E is that transition point. F is the transition point over here. G is the highest up that goes on this. There's friction here. The rest is frictionless. So the object's going to start here, move up to there, come down, move, get up to G, start sliding back down. So H is that point. It's at the same place as it is at F, just going the other direction. H, I, and then J is when it stops moving up in that direction, and it's going to come back down. But J is when we stop the problem. There is two-dimensional motion here. So I would specify we're dealing with just the horizontal component of it. So I'm just concerned about the horizontal plus minus 0. We can establish our 0 somewhere. Let's establish the right is positive, and I'm going to establish that is 0. Now there gets to be some nuances here. So for instance, is H the first moment it is on the ramp, or is H the last moment it is on the flat surface? Because an object will transition, and it does matter when we start getting into some of the subtleties. So let's just go ahead and make all of these object is completely on flat surface. So for E, it is just after the transition off of it. For F, it is just before it transitions to the slope. H is just after it comes off the slope completely, and I is just before it goes onto that slope. So that is a test level problem. And we will go over that on Tuesday. I should have the Monday lab posted today. So please print it out before Monday. And have a nice weekend. I think we're done at 12:20.
What is the lab on Monday?
Pardon?
What is the lab?
It is going to be sort of a conceptual approach of exploring the plus minus zero. Yeah, what I write down, we're done at 12:20. Yep, do.